Today's session brought to you by the NetApp Customer Success Program is OCI Unwrapped. I personally put this together. It was suggested by some of our technical people that they might like a rundown on what are the bits and pieces that make OCI what it is. As there are a lot of components in there, many open source bits and pieces, and that they thought that people would be interested in what some of those components were, what they did, maybe even a little bit of inside knowledge on why we pick certain ones to use, etc. So that's kind of the basic gist. My name's Charles Fox. I am a part of the customer success group here at NetApp. I consider myself somewhat qualified to do this. I do have an engineering and programming background. Did a lot of work with MySQL and the like. I am I'm certainly not up to the scale of our developers here at NetApp, but I think I have enough of a grasp on this that hopefully you'll get a pretty coherent look at this. So, let's see. All right. So this is our agenda. Very quickly, what I'll call a brief history of OCI, just a little bit on where it came from, as it was an acquired product. Its original components were not generated at NetApp, although we have had it for quite some time now. Then we're going to take a look at the block components of OCI, the components at a high level, take a look at some block diagrams to just give you an idea of how they interact. And some of those are listed here. The collection server, the data warehouse, the ADE, data acquisition unit, and the Ethernet monitoring unit, or EMU, as people like to call it. I felt, I put this in at the last minute, the information in here is largely publicly available. There isn't a whole lot of secret sauce in here. And so if you dug around and wanted to Google all day, you could probably find out similar answers to what you're going to see here. It's not meant as a deep dive. I am not a subject matter expert on every one of these components. Like I said, I managed to have background, operational background in some of them, not all of them. So if you want to play, as we like to call it, stump the chump later, if you ask me a question that's very, very deep on a particular component, odds are I'm not going to be able to answer it. But I will try. I do reference other companies' products and other bits and pieces in here. So the legal people say any references to trademarks, etc., are owned by the respective people and not property of NetApp. So that being said, let's get right into it. Brief history of OCI. OCI came from another company that we took over in acquisition. It was originally known as Sandscreen, and it was changed to OnCommand Insight to fit the branding of the various other command and control products within the NetApp universe. January 2008, we acquired the Onero Corporation, which built the original Sandscreen product. In the decade that's gone since then, we have been obviously developing OCI internally. Just as a little point of interest, and some of you who use this stuff in production obviously know, if you dig into things like directories and various bits and pieces of OCI today, you'll find references to Sandscreen and Onero still littered amongst the code. It was simply easier to leave those things in place than to try and change them. OCI has also contributed to various other technologies at NetApp. We've leveraged those pieces in things like Cloud Insights. I say leveraged, just to be clear, Cloud Insights is not identical in architecture or deployment. A lot of people say that. They say, hey, these new cloud products are just hosting OCI, right? Not so. They're being redesigned for that. However, a lot of the technologies, especially things like how the data sources are architected and used, are very similar between the two products. Okay, block diagram. This is very simple. I didn't even have color on it. I clipped this out of the OCI documentation, but it does give a fairly simple and straightforward look at the major pieces that do make up the OCI system. Obviously, the collection server is the central point. Communications between all of these components, we try very hard to follow network-friendly and industry-standard communication mechanisms like HTTPS, but the API, the Ethernet monitoring unit, et cetera, all of these guys communicate to the central OCI server. There's also other optional components like the data warehouse. The data warehouse and its Cognos reporting engine live with a separate SQL database on a different server. And but this is just to give you a general idea of how all the pieces fit. Okay, well, we'll start with the most central and most important piece of OCI, and that's the collection server. It's an absolute minimalistic system to have just the collection server, and of course you can add on other modules and components from there, but you don't have OCI unless you have at least this. It's essentially the container for pretty much all the OCI components. Data warehouse could be considered a separate instance. It's key, one of its probably key functions, at least when I researched how this is put together, is the server is sort of a container for a lot of the other components. It hosts the UI, it hosts the ability to service the APIs and things like that. It also hosts both the user interface, which you use for reporting, that kind of thing, as well as the older Java interface as well. We also have, so really it just contains a lot of these different components. It executes a number of tasks. It's really sort of a task master and scheduler is one of its key components. Acquisition, this is one of the reasons you buy OCI. The data sources are all unique. They have to point at unique systems. How do you get information in and out? I can tell you that we use command line interface, essentially command line screen scraping, for lack of a better definition, to pull things like metrics back and other things like SNMP, vendor APIs, etc. So one of the reasons, like I say, you buy OCI is you get this plethora of data connectors that are built. None of them are really the same. They not only collect the raw data, but one of the more key things about them is that they define the mapping and normalization of data to get into the OCI database and put it in a form that's usable in things like reporting. The server collects this data, does some normalization on it, and passes that information to either Elasticsearch or MySQL for storage on the machine. It also performs things like real-time analysis on various things like thresholds and triggers that you can define, and it's looking at the incoming data streams and obviously reacts appropriately when one of those thresholds or triggers is violated. It coalesces the data into proper formats. Things like, should these statistics be collected on a minutely basis? It does things like fixed time quantas between collections of input data. It also does the processing of dashboard information, the rendering of the UI, rendering of information on it, as well as other housekeeping tasks that range from simple things like managing SMTP messages that send out when alerts go, license management, and things of that nature. So, key component, central to the whole system. The data warehouse. This is optional. I certainly think that most people would find it a very useful piece, but the data warehouse takes the 90-day database, at least on recent versions of OCI. Earlier ones were less than that, as little as about 7 days. But now, if you're on a recent version, you get about 90 days worth of data on the collection server that you can report and trend on and that kind of thing. You want to pull that out over a larger period of time, you need the data warehouse. And it's essentially a database of collected data over time. It's a little more than just a database. There are processes that do things like an ETL. That is, they go out and query the collection servers, and they do an extract, transform, and load that takes the data and coalesces it even more, massages it some more, and puts it in the database for long-term storage in the data warehouse. The data warehouses can become enormous in size, and you can trend well, across years of data if you have the disk space and interest in doing so. It has internal tools. It has its own reporting dashboard-like engine, very similar to the OCI collection server, so that you can build, basic dashboard and simple reports on it. It also uses IBM Cognos for more sophisticated reporting requirements. And Cognos is one of the more interesting third-party pieces in the OCI world. We'll talk about that a little bit later. The core components of the data warehouse are the MySQL data engine, Windows Server, which is interesting because it's one of the few components that is Windows Server specific. And that's why I called it out on here, is that there is an operating system requirement there. And that's due to the fact that the versions of Cognos and things that we license today were only available in Windows. So that sort of forced the specific platform issue on the data warehouse. Now, the data warehouse also, when we talk about bits and pieces that underlie the core components, it includes things like the WebSphere application server and a simplistic version of the Informix data engine, especially in version 11. And this is an interesting thing to be aware of because the Cognos system creates a lot of unique dependencies on installation that we have been struggling with. It's much more difficult. It has to have a much more refined environment, particularly from a security context, to host all this. And the data warehouse, last but not least, of course, is wrapped in custom code built by NetApp Engineering that does things like schedule reports and various other housekeeping tasks as well, just like the collection server does. The ADE, the Anomaly Detection Engine. This is an optional component that you can download, runs on a separate Linux box. It is a machine learning system that collates the metrics in near real time. What it's doing is it's looking at the OCI collection, the collection services, and it's taking that information and it's analyzing it in real time. And what it does is it has an integrated learning engine that's also plugged into Elasticsearch. It's called XPack. We'll talk a little bit more about that later, but it essentially builds a baseline of data points over time. And it then compares this baseline to what it sees currently. And that, the greater the divergence, the greater the anomaly score. So interesting little piece of technology, and in that it's a little more interesting to work with in that it is not completely deterministic, like, say, a threshold or another trigger. It manages itself over time. So it's only as good as the baseline it's provided. In the first time you install ADE, for the first hour or so, you're not going to get much meaning. The longer it runs, the more the baseline adjusts itself to reflect the behavior of the system over a longer period of time. So this is interesting. We'll go back to some of the internals on this a little bit later when we sort of kind of break things down to even smaller pieces. And I often hear, hey, this is free. There's no licensing required. That's true in the extent that it does not have a separate license key associated with it. However, you do have to have the Discover and Perform modules installed, but there's no key that you load like you do for the other components. So it's not no licensing required. It's just if you have the appropriate licensing, it's not an extra cost to deploy this. And this is specifically a Linux box, so there's no costs for the OS as well. What are the metrics that get fed into this to create the scores? I get asked this all the time, and I have made an effort to hunt through NetApp documentation and the like, and there isn't any published set of which statistics and how they're weighted and that sort of thing goes into creating the self-adjusting scores. So I'd love to tell you more, but long and short of it is I think that's considered trade secret. So secret sauce asks no more. I can't really get into a lot of detail. I can say that I know that they're constantly tuning from release to release what sets of metrics they can correlate against each other to get the most interesting results. Okay, next big piece. Obviously, OCI is a very web-centric system, and it has to have some sort of web services enabling platform in the middle of it. And that's Wildfly. This is formerly known as the JBoss application server. It is a Java-focused component. It is also available as open source and supported by the Red Hat people. But this is what we chose to embed into the OCI server. And why Wildfly? Because there's a lot of other potential and very good alternatives as web services engines. Partly because Wildfly was an application server as well as an HTML simply rendering component and UI presentation tool. It has bits and pieces built into it that allow the implementation of things like the REST API. So the Wildfly server gave us a good jumping off point to do more than just rendering of the UI, but to make it possible to add external interfaces and things. It also has a reputation for being fast and relatively small in terms of memory footprint. So that's really why we picked it. Now, why not? Why not Apache? Why not some of the other alternatives? Again, less focused on use as an app server. They were older code bases. They weren't really as up to date as Wildfly was, and they're typically heavier in resource usage. So the next logical question is, thanks for that interesting data point that you use a less common server than Apache, but why do I care? Well, the answer is typically you don't. If you want to think of OCI as a black box environment, that's great. Just use it as the owner's manual suggests. But knowing that it's Wildfly underneath will become important in some cases. I've had to go through a couple of situations where people required custom certificates for high security environments or modifications to server authentication for multi-factor authentication. At this point, you're going to want to know that it's Wildfly because you may be asked by support or by the installation guides to go in and start mucking around with configuration files on this. And obviously, they're going to be different than if you're an expert with Apache. All of the stuff is going to be in different places. Being aware that it's Wildfly and being able to, research information on its configuration file locations and things like that are going to help you out if you find that you're doing some unusual tweaking to the system. So that's pretty much why you care. Data acquisition unit. I've heard it also referred to as remote acquisition unit. Names are interchangeable. This component it serves a couple of purposes and is actually becoming more important as time marches on. The data collection processes use lots of different methods to go out and touch controllers and devices. And we try our best to stick with, straightforward things like an SSL session on 443 to a command line interface. That's something that tends to be firewall friendly in a network environments. However, there's other situations where data sources require some oddball port that was designed for some specific management tool for a particular controller or something of that nature. So it may use some port range or unusually ill-defined port. That end, a lot of tight security administrators, it's like, look, I open as little as humanly possible. I don't want to open port 1321 so that I can talk to an HDS controller. So the data acquisition unit can be put on the other side of the firewall where maybe there isn't so many restrictions on things like ports. Run the data collection services, package all that up into a single stream, and bring it back over something that's well defined like 443. So this minimizes exposure at the firewall level to having to open up other pinholes and things like that. Something that nobody likes to do. The other thing is, what if you're in a completely disparate network, like the cloud, or even another data center, but you still want to be doing collection on that. This allows you to run that data over the internet, encrypted format, and compress down to essentially a single stream. So as cloud computing becomes more and more important, the data acquisition units become a more and more important potential component, especially if you're doing, it's funny, the on-prem and off-prem worlds are kind of flipping, so that now all the OCI components are ending up in the cloud, and maybe you're talking to cloud components as opposed to on-prem. But this allows things to go both ways, enhances security, and makes data acquisition across disparate nets easier. The EMU, everyone insists on calling it EMU. The Ethernet monitoring unit is, it's not used all that much. We don't see it being, it's probably the least deployed of all of these components. And the description that you see there in the quotes comes right out of the NetApp documentation. It is essentially a network level monitoring unit that I liken to, just to be colloquial about it, I said almost like Wireshark for OCI, because that's essentially the way it acts. It listens for data at the network level and does some basic packet disassembly and that sort of thing. And it's used to discover NFS operations, what volumes are mounted by whom, and that sort of thing, by taking apart the address information inside the NFS packets. And it's so it's very specific in its use case. The other thing about the EMUs, as we like to say, is they do have somewhat unusual hardware requirements. There's I believe it has a specific set of supported NICs, which network interface controllers, which I'm sure has to do with the fact that this thing is essentially running in promiscuous mode like a network sniffer. And that's something that you want to limit to a certain set of hardware if you want it to be reliable. So, things to remember here are very, very specific to monitoring NFS operations. This runs on a Linux server as well. There are special hardware requirements, limited use cases. We're not seeing it that much, and it diverges from most of the other data collection schemes that we use in OCI, like hitting a command line or hitting a REST API. I know that architecturally the engineers would prefer something a little more elegant. So I know that there's active development work going on to see how we can get these kind of statistics without having to result to packet disassembly and that kind of thing. So that's the EMU. And now let's talk about things at a little more granular level. So those are the highest level building blocks, right? Now we're going to kind of move down the food chain, and these are my comments on what's in there and why, and some of the possibly unique reasons. You might garner a little bit of backroom talk about why we pick certain things and some interesting data. So we'll just go through the various components here. Now, I can stop for questions. I tend to ramble on if not interrupted. Or we can, which I think is probably preferable, we can wait till the end and I'll open it up for questions and we'll try and answer it then. So if everyone's okay with that, I will move on. All right. The bricks in the OCI wall. Let's start with Java. From an end user's perspective, Java is primarily used to enable the legacy console in OCI. We would love to see everything being webified, if you will, and we're rapidly running in that direction because we don't like having to have the Java applet in the associate runtime environment, things like that associated with it. It just makes for certainly a more difficult end user environment than just a browser. So we're definitely headed that way. We now require a 64-bit version 8 Java runtime to launch this UI. It's also used as a vehicle to program against OCI. Most people tend to gravitate towards scripting languages like Python or Perl now, although I have seen some work done in Java to talk to the OCI system. It is also used internally. I don't want to imply that the only thing that we use Java for is the legacy console. That's not true. There's components that do things like rendering and animation of data and things of that nature that are actually Java based. And this also ties back to Wildfly that we talked about earlier, the JBoss app server. That's Java centric and allows us to leverage Wildfly's abilities to consume Java applications and that sort of thing when rendering on the interface. Okay, MySQL, one of my favorites. I, in a former life, had the distinct pleasure of working on monitoring 300,000 MySQL databases running in Azure and Amazon, AWS services, and things like that. So MySQL, I was amazed at the reliability and the robustness of the product. It is currently the most popular relational database in the world, at least Oracle still claims that to be true. There are some people who might question there's some others, but very well tested. This is a battle-hardened piece of work. It's just as good as the commercial alternatives. I worked for Microsoft for many years and was thoroughly instructed to never suggest that there was anything better than Microsoft SQL Server. Hey, great product. I won't say anything bad about it, but MySQL is very much the equivalent of everything except, certain special use case databases that are available. It's great for embedded project because of its licensing scheme, essentially free. Hey, that's one of the reasons we used it. I won't sugarcoat that. Is if you don't have to pay a royalty on a database engine, that just keeps the cost down. There's a huge ecosystem of tools. Since we embed it in the server and data warehouse components, you probably don't see a whole lot of references to direct interaction with SQL, although this is something that absolutely everybody does. But things like the SQL console, the command line, Heidi SQL, other, just a huge ecosystem of tools that you can interact with this with if you choose to go outside of the raw OCI world. Now, every time I bring up MySQL, inevitably there's well, isn't MariaDB better? Or, gee, given your large data sets, would Hadoop have been a better choice? And those are largely academic questions. At the time, over the years that OCI was developed, MySQL was probably the preeminent product then and the most stable, and predates things like Hadoop and stuff like that might have in some ways made more sense. So we've stuck with it. It's still the most popular version of the database, despite the MariaDB pundits saying, hey, it's better, or this is better, or that better. It's well understood, so there's a lot of skill set around it from our developers' perspective. However, it's not. It says at the bottom, it's obscured a little bit by my title. I apologize for that. I'll fix that. It's not always a perfect answer, and the perfect answer is because much of the data in OCI is unstructured, and when we moved to later versions of OCI and started using the Elasticsearch components, it gave us the ability to do things like schema-less updates to the database engine whilst running. And that enabled the ability to do things like the SNMP components, because you didn't know what you were going to get with that, and we couldn't adjust a structured schema on the fly easily. So we'll talk about that in a minute. We'll get down there. But MySQL, great product. We'll talk a little bit about versions and things at the end, because I'm sure that's going to come up. Elasticsearch. Elasticsearch is a search engine and a database that, as I just mentioned, is better suited towards less structured data. It actually stores things as documents. It's almost a form of almost like free text search engine, but it stores them as, to quote the Elasticsearch people, serialized JSON documents. It can dynamically create indexes and things of that nature on the fly, and can operate without a predefined schema. So Elasticsearch was plugged in to take care of these situations where we weren't really sure what we were getting in all cases, and how can we create those and query against those and things like that on the fly. Next question, can I access Elasticsearch directly? Yeah, theoretically you could, and I've actually heard of people sniffing around the APIs for Elasticsearch and thinking, wow, wouldn't it be cool to maybe get at some of the data that way? So I think theoretically it's possible. There is absolutely no documentation or support on how to do that. You should use the REST APIs for that, and you'll hear me reiterate that point a couple of times. But I have to admit, I have been asked, hey, can I go at Elasticsearch directly? We would discourage that. Okay, so I'm drilling down on the individual components. Wildfly, we already discussed that in the high-level section, so I won't go back to that. Cognos, the report engine for the data warehouse. Not a whole lot of gray area on this. People either like it, think it's a great tool, or they hate it. It's, I could say that only because I live with a lot of questions on Cognos coming in all the time. However, whether you love it or hate it, it is one of the premier report generation and analysis tools that is out there today. It's got a very big following, lots of training on it, relatively good support from IBM and things of that nature. If we were to try and reproduce the capabilities that are in the Cognos engine, it would require a very significant number of developers and hours to achieve parity. So, we decided that the reporting and data analytics business was not necessarily our forte, and that OEMing Cognos to go in the system would be the way to go. We've embedded it with the OCI Data Warehouse Installer. As I alluded to earlier, Cognos brings with it a bunch of interesting pieces, especially in version 11. It installs WebSphere and a bit of Informix, and we have discovered that there are some pretty significant security issues, things like proper generation of service account names and things like that. If you're in a lockdown environment, I encourage you, before doing a Cognos 11 upgrade, to look into this and talk with our support engineers or your SE or whatever, because this can be mitigated and it can work in these high security environments. There's got to be a bunch of things that you want to do. Strongly suggest you do a test instance with the actual environment that you're going to put it in, so that you can see how it interacts with things like group policy and password policies and the like. The best advice I can give you for learning Cognos is probably the best thing that I have is we've done a video series on Cognos. It's been placed up on YouTube. Some of you might have heard the name Mike Moon, who's head of the Customer Success Programs Services Organization, and he has generated a whole series of these videos. And feedback I get on them is they're quite good. If you're focused more on Cognos 11, There is a set of videos coming out for that. If you're really desperate to take a look at them, contact your customer service representative at NetApp, and they might be able to get you a pre-release look at some of those for Cognos 11. I know I've been able to provide them to a number of my customers. So if that's something that you're really interested in, please ask. Now, as I sort of alluded to earlier, one of the beauties of MySQL is that you can use other reporting tools against it. Cognos is bundled. That's what we recommend. But even SQL Workbench that comes with MySQL or the command line, you can use those to get at the database. And if you stick to the accessing the data elements that are in the blessed schema, you can get some pretty good results. In fact, direct SQL access or making MySQL queries against the database, the data warehouse, etc., sometimes are the only way to actually get the results you want. So, keep in mind that sometimes raw SQL may be your best bet. It certainly does make things more complicated than drag and drop, but the option is there. And if you can get something that will connect to a MySQL database, you might want to explore other possible tools to connect up if Cognos isn't your cup of tea. Don't let me think that I'm bashing Cognos. I'm not. It is just that a product of its complexity takes some time to master and has, like I say, love-hate relationship with it. Once you're good at it, you do an awful lot with it. I talked a bit up front about data sources being a component of OCI. And they are very, very important. And I'd like to reiterate, it's one of the reasons you purchase OCI. You would not believe how much engineering goes in to data sources because each and every one of them is a work on its own. I mean, OCI, we push as an agentless component. That is true for the most part. There are alternatives like CollectD that do exist. That's a different discussion. I actually did a session on CollectD some time ago. It's basic. It's basic. So if you want an intro into how to use it, you can go out and check the YouTube videos for CollectD. But the data sources were designed and built so that OCI could remain as agentless as possible. They're a significant effort, and the significant effort is that every single one of them may use a different methodology to get at the data within that switch you want to talk to or disk controller. So imagine if you were doing this yourself, you would have to have familiarity with the command line interfaces, command formats, etc., of hundreds of devices conceptually. It's not something that a single person could have the knowledge set to do. That, and more importantly, you have to understand what you're getting back. And you have to take what you're getting back and you have to normalize it so that when you compare it against other sets of data, there's some consistency in terms of things like the time these were collected in. Are we talking megabytes versus kilobytes or whatever? We have data scientists who just literally sit down and analyze this stuff, look at the schema of our storage database, look at the events and information being brought back, and they, to use a technical term, munge all this so that it works well together. Consequently, I get asked this too, is there an SDK? I want to create a data source of my own. There really isn't. We will work with manufacturers directly to help develop these things if they're willing to work with us, but there is no such thing as an SDK for making your own. Once again, SNMP, REST API are your best alternatives for figuring out how to get oddball data that we don't necessarily support into the OCI system. However, you get to figure out the normalization of that and how to use it successfully. So that's a lot of work that we've done, and that's why data sources are cool. All right, this is one of the more esoteric pieces of OCI that I had to do a little digging around. If you take away one thing, this might be the gem that tells you a little more about the secret internals of things. XPack is an extension to Elasticsearch, and it contains the machine learning bits that we've leveraged to do things like the anomaly scoring. It is open source, but it's got some restrictions. It's not like a GNU license. It's a specific Elasticsearch license, so it's kind of open source, but not exactly. You can even go up to GitHub and look at these examples and get an idea of how we used the XPack engine to do some of the anomaly detection scoring. I made an effort to find out in detail how some of this worked, just because, as luck would have it, I date myself. Years ago, when I got out of college, one of my first jobs was, and we're talking the 80s, was some AI work. So things like Bayesian distribution modeling was something that I actually had to do a long, long time ago. And I was hoping to find out some really nitty-gritty details on it. But apparently it is proprietary. It uses a series of correlating mechanisms to do this. I'm fond of Bayesian distributions. Those are essentially, in my day, we weighted neural networks, which is something that's becoming cool again 20 years later. And so it really is a learn by doing approach. It's not rules-based modeling or anything of that nature. There's the Wikipedia description of Bayesian hierarchical modeling if you want. It's full of lots of interesting math. So if you want to really delve into it, that's where you go. But if you're really curious about some of the internals on how we do things like anomaly scoring, go out to GitHub and look at some of the examples and things like that, and it'll give you an idea of how we implemented it internally. Okay. Yeah, we're coming to an end. So, well, 1:45. That's about what I thought. With great power comes great responsibility. It's that you could use the knowledge that you may have learned today about these open source pieces, or going out to the sites to support those open source pieces, and probably use that to do some interesting things to OCI. To quote our engineer, Matt Ostaguy, don't do unnatural things with a product. How he likes to put it out. If you were to use any of these things, just remember your supportability, upgradability, etc., is absolutely out the window. We could make a minor change in a point release and it would break some interesting script or something that you used running against a non-standard API. So please, stick with the REST API. A lot of times people say, hey, I can't find any documentation on it. Well, that's because we hid it in the help system on OCI itself. So under the help section, you'll see a whole bit on how to use the REST API and its calls. And there is also a graphical schema reference for the database as well if you want to do some direct SQL queries. Direct SQL queries are somewhere, they're not considered a hack. As I said, they're considered necessary. But in general, even if you can avoid that, you probably want to. Okay, a little bit on versions. This is as of OCI 7.3.5. These are the open source versions of the tools that we embedded into the product. This is usually of interest to people. I'll tell you when it comes up is people will say, I ran a vulnerability scanner and gee, it says that my SQL 5.7.x has a code execution capability. We don't like that. What can we do about it? Well, because this has come up a number of times, so I've had to deal with this question. Unfortunately, it says at the bottom you can't upgrade individual components. This is a lot of guys who are especially familiar with the open source world will go, oh, well, let's just upgrade the underlying MySQL engine, and it doesn't, 5, 7, 6 doesn't have that vulnerability, so let's do that. You can't do that. If you upgrade these pieces yourself, you will have rendered your site unsupportable. Now, product support does have patches and upgrade mechanisms that have been worked out to address specific problems. So, and I'm not saying that these things are locked in stone at these particular versions, but upgrading them is something that you absolutely want to do with the blessing of the product support guys and following the procedures that they do. So please don't get all cavalier and go and say, I'm going to put this on the latest version of SQL, because the results will probably be unhappy. There. Let's see. That's what I got. That is a look under the covers at OCI and some of its underlying components. If you're a longtime OCI user or a smart sysadmin, I don't think I probably told you anything new, but hopefully just a general refresher on what the bits and pieces are and how they interact will allow you to understand why your OCI system does what it does. And that allows you to be more efficient at figuring out strange situations or wondering why something worked the way it did. So hopefully this was of value to you. It says NetApp Confidential down there, but if you really wanted a copy of this, I think I could arrange to make those available as a PDF file or something if that's something that people want to do in the future. Like, once again, contact your customer success representative and we'll see about making this available. But thanks for showing up. Thank you for your attention. If there's any questions, I will do my best to address them. But as I said, I'm not an SME on all these pieces, so you may be stumping me.